In this optional segment, I'll try to explain how you can also calculate frequency densities by using a so-called standard bin size. This is the quick version of the video. If it goes too fast, simply have a look at the slightly longer version where I'll go over the steps in more details. Frequency density was actually used to check which bin is most crowded. It's defined as the frequency that would be in each sub-bin if a bin was to split up into these sub-bins with a size of 1. It was calculated by taking the frequency and divide by the bin size. So here's an example where, for example, there were 8 people who drank between 5 to 7 drinks. If we would split this up into sub-bins of a width of 1 each rather than a width of 2, then the total of this should add up to that same 8. And indeed, to be fair, we simply therefore divide 8 by 2, which is actually 4. So 4 is the frequency density. Now, this is one way of doing this, but as you might notice in this case, almost all of these have the same bin width. And it takes a little bit long, especially if only, for example, you have 10 bins and only the first and the last one is different, to do these calculations. So instead of having to split each of these up into a size of 1, you could also say, well, we do it slightly different and we split them up into bins with a so-called standard bin size. In this case, the standard bin size would most likely be 2 because that would avoid most of the calculations, but you can actually use any number you like. However, by using the bin size that occurs most often, you have the maximum benefit of reducing the calculations a lot, as will be shown on the next slide. It's usually the bin size that occurs most often, in this case 2, that will be selected as the standard bin size. So I'll be using that also in my example here. Now the first thing we need to do is look at all the other ones that do not have the standard bin size. So in this case, the first one is a bin size of 1, which is actually only half of the standard bin size. A bin size of 4 means actually that you have 2 times the standard bin size, and 8 in this case means that you have 4 times the standard bin size. The frequency density is now calculated by taking the absolute frequency and divide this by the number of standard bins it is. So we get 6 divided by a half, not divided by 2, to actually get 12. And for example, 10 divided by 2 equals 5. To highlight this 5 and what it actually means, let's have a look at the 7 but under 11 category. We can split this up in the standard bins with a range of 2, 7 to 9 and 9 till 11. So together this still is 7 but under 11. The total of the frequency should add up to 10. So indeed each of these two now actually gets 5. We can do the same for 11 but under 19. That actually will look like this. Each time now again with the standard bin size, so each of these has a bin size of 2. The total should add up to again this 10 now, and 10 divided by 4 will actually give me the 2.5 on each of them, which is indeed the frequency density listed here as well. Here's a comparison between the two methods, the unit size where the bin size is actually 1 and the standard size that we use in this case of 2. Notice that the results are also simply times 2 every time, so it's this one times 2. That means that the biggest one remains the biggest, the smallest, and proportions are actually also all the time the same, which is actually why we're doing this. We want to see which one is most crowded, which one is least crowded, and if we multiply anything by a fixed number, the biggest remains the biggest and the smallest the smallest. The benefit of having the standard size is that these we don't actually have to perform any calculations on because they had the standard bin size. Well, if we had the unit size, then we actually also still had to do a division between these one by one. If you have a longer table, that might take up quite some time, and therefore sometimes the standard using a standard size can be beneficial. If you do use a standard bin size, please make a note underneath the table that you've done so it's also clear to any reader.